Now let's look at exercise 3, best project combination. So this is the one where we're going to use a combination of solver and also the subtraction and addition methodologies, okay? So what happens here is that we have these options whereby, let's read the question. A civil engineering firm has 7 potential projects it can undertake. The firm cannot work on all 7 projects due to staffing limitations, only 25 engineers available on staff. The number of engineers required per project and the NP's project are available in the Excel spreadsheet. So we have the project 1 to 7, required engineers, the NPV, and whether or not we should invest. Okay, so the first question we have is that if you had no limitations, who could work where? Which projects would you invest in? So let's look at part A. Right, we have project 1, 2, 3, 4, 5, 6, 7. Okay, and we just cut and paste this whole thing. This makes it easier that way, right? Okay, let's just grab the whole lot, put it here, and bam, off we go. Okay, so this is invest, and detail that, make that a nice pretty yellow or orange. Okay, so what we'll do, we have that in terms of so we'll prepare everything for the rest of it. We would have that's for part B. Okay, and just prepare it for part C. And we have also part D. I'm just preparing the tables for all of it. Okay, so part D. So what happens over here, we have these are the 4 parts of the questions. What we're going to do next, okay, is that we have our staff constraints and our NPV. This one, we want to maximize it, okay, and this one has to be less than or equal to 25, okay? So what we have to say over here, okay, is that we have to equal some product of this and what we invest in is 0, okay? And the NPV is going to be the summation, the sum product of that too, right? So equals sum product of this bad boy here and these ones over here. Okay? So basically, that is just go and do that for each one. Okay, so let's check. Let's check. Yep, that's all good. All makes sense. Okay. So this is all us just stuffing around with the optimizer. Right? Okay, so basically what we're going to do over here is let's start off with the optimizer. Okay, the solver. Right? So what does the solver require us to do? Okay. So, okay, in this case, we want to maximize. I'm going to say over here, it's going to be going to maximize D12, which is the NPV, okay, by changing variables D2 to D8, all right, and we subject to constraints that D2 to D8, these would be binary, okay, and that B11 must be less than 25. Okay, so that should really be, just has to be less than 25, okay, and what happens that, and we just remove this because this is not relevant. Ooh, oops. Okay, there we go. Okay, so now we solve it. So this is our answer. Okay, that is our NPV. All right, so this is the answer for part A. So it would be 1100111, right? So this is our answer for part A. So in our solver, it was pretty basic. All we had was to maximize the NPV, max, changing cells to the invest cells, making sure that the total number of staff was less than or equal to 25, the average minus. So this is the simplest version of the solver. Okay, so let's look at part B. Since project 1 and 2 require special engineering knowledge only one engineer has, only one project between the two can be undertaken. What is your best combination now? Okay, so what this actually means is that you can only choose one or two. Okay, so remember what we had before. We actually had the let's say project 1, project 2. Okay, so you can only do 1 0 or 0 1, 0 0 or 1 1. No. Okay, yes, yes, yes. Okay, subtraction formula would be so what we can do is that it has to be basically 1 or less than 1. Okay, because you can either do it, you can only do 1, right? You can't do 1 plus 1. Okay, so it'll be, say, look at it this way. Okay, so it has to be 1 or less than or equals to 1. So what we actually do over here is that we'd actually say that we have the requirement and 2, choose only 1. Okay, so the value that's important over here is going to be 1. So what we're going to do is that we have the solver function. Okay, we kind of go that okay, so we add a constraint whereby that plus this must be less than or equal to 1. Okay, D2 and D3. Okay, wait, so what happens is that, let's look at this guy. Okay. Okay, so it would be this plus that. Okay, so let's solve it. So we said that f9 must be less than or equals to 1, so let's solve it. Okay, so it's 1 0 0 1 1 1 1. So what happens is that the answer is 1 0 0 1 1 1 1. Okay, so that was when we said that we can only invest in either project 1 or 2. Okay, so we set the constraint over here, right? So now part number C, in addition to the info in B, project 5 cannot be undertaken unless project 4 is chosen. However, project 4 can be undertaken independent of whether or not project 5 is undertaken. So what is the best combination now? Okay, so it's scenario, so we put out all these scenarios, right? 1 2 3 4. So project 4, project 5. You can only have 1 with 1. You cannot have it with 0. You can have 1 and 0, okay? But 0, 0, that's possible. 1 and 0, you can't have that. So you can choose to do no projects. You can't do project 5 or project 4, but you can do project 5 or project 4, and you can just do project 4 by itself, okay? So this is the possible, and we use subtraction, okay? So we just go. So basically, when we talk about subtraction, it's just trying to find a combination where it's actually possible. So we like these ones. We know that these are where it's possible, right? So therefore, we're going to say that as long as it's more than 0, then we can proceed. Okay? So basically, like to do 5, you must do so I'll put it here, right? Okay, to do 5 must do 4, but 4 alone is fine. Okay, so in order for that to be true, okay, we have to go like 4 minus, wait, 4 minus 5, okay, and we must say that this thing has to be less than or equals to 1. Wait, this one has to be more than 0. Okay, because basically what happens, the no condition is -1. So as long as it's more than 0, it's actually okay, right? So basically this equivalent is that. Let's make that different color. Okay, so we go to solver again. In solver, we now add another condition. So we had f9 is less than or equals to 1. Now we delete that and we go add, okay, a condition whereby this guy has to be more than 0. 1 equals 0. Okay, so we solve. And it gives you 1, 0, 0, 1, 1, 1, 1. So this is the answer 1, 0, 0, 1, 1, 1, 1. Okay? So basically, all we're just doing over here is we're using scenario projections, and we're actually just working out using subtraction or addition what conditions we can actually make the yeses possible and actually apply to here. Okay? So now this is for, this is actually going to be for part D. Okay, so for part D, what's going to happen here, right? In addition to the above info, because of existing contractual arrangements, if project 7 is taken, it's not possible under project 6. What is the best combination now? Okay, so the next thing we have is that if choose 7, can't do 6. Okay, so basically we can have the scenario of 1, 2, 3, 4, project 6, and project 7. Right? So if we don't do it at all, that's fine. If we do 0 and 1, it's fine. Can we do 1, 1? That's no. Can we do 1, 0? That's a yes. So we can do either not do project 6 and 7 at all. We can either do project 6 or 7, but we cannot do both. Okay? So that's easy. So we just go with the addition, right? So it's going with plus. So what happens over here, we can see that if we want the greens, okay, we just have to have less than 1. And that's it. Okay, what if it's subtraction? What's the problem over here? Okay, let's see. Okay, so if we did subtraction, the issue over here is that, like, we have two conditions where it's 0 and it's 0, and this is a yes. So by doing an addition, that actually allows us to put a simple set of conditions that less than 1 means it's a yes. Okay, with this one, well, we get 0 for both conditions. We can't use the subtraction method. That's why we must use the addition method. Okay, so that's why. All right, so with that, all we just have to do is go to solver. Okay, and say that it has to be okay. So what happens is that if you choose 7, can't do 6, what we're going to do now is we're going to have a condition when you have equals to 6 and 7. Okay, and what happens is that it's a plus, and this one has to be less than or equal to 1. Okay, so basically that's going to be a blue. We're going to go into solver again, and now we add another condition that this bad boy here has to be less than or equals to 1. Okay, all right, so now what we see over here, we have the conditions that you choose 7, you can't do 6, which is F28. Condition of F18, which is to do 5, you must do 4. And the rest of them stay the same. We click on solve. And we get let's see. D8 and D7. Okay, so we have here's 1, 1, 1, 1. Okay, so basically this is the answer I actually get to 900, 10 here. And does it satisfy the conditions? So it satisfies the conditions that to do 5 you must do 4. So it was 1. Okay, so maybe there's a possibility in here that we also need to add the condition of that has to be less than or equal to 1. So let's solve that. Okay. So basically, in order to actually, so what happens for part D, it was actually conditions of A, B, and C all together, so that was the answer. Over here, right, where we have that, and that was the answer. So, okay, so what happens is that in the most recent one, this solver, okay, so we maximize the NPV, all right, to maximum by changing cells D2 to D8. Subject to the constraint that B11 had be less than 25, and that these elements have be binary, and with these conditions. So this condition about 0 was for part C, this F9 was for part D, and this one F18 more than 0, less than or equals to 1 is for part B. So we had 3 conditions, we solved it, And that's the answer that she gave. So that's pretty much how we actually use like subtraction and addition. It's just to actually get the conditions whereby the possible combinations are acceptable and they'll be keyed to solver and it solves the equation. So that's pretty much it. I hope you enjoyed that tutorial and that please do try it by yourselves, okay, without looking at the solutions and keep practicing your Excel skills.